Hello everyone, today we'll talk about the problem minimum difference between largest and smallest value in 3 moves. We're given an array of integers. We're interested in the difference between the maximum and minimum in that array. We want to minimize that difference, and to do that we can perform at most 3 operations. In a single operation we can change any value in the array to any value that we want. So the first thing to notice here is that in a single move we have to choose an element and choose what to change it to. These are 2 different choices, and at least the second part we don't really have to worry about. That's because if at the end we have some minimum and some maximum value, then it suffices to change or to have changed the value of the number that we've chosen to anything between this smallest and largest value. In particular, if in our array there are at most 4 numbers, then the answer is always 0. That's because we can choose 3 values and change it so that they are equal to the last one. So in other words, make the array consist of all the same numbers. And in that case the answer is 0, and it's impossible for the difference between the maximum and minimum to be anything less than 0. That means that our operation can be thought of as just removing an element. And so, which elements should we remove? Well, it makes sense that there is no point in removing an element from the middle of the array if at the end it's neither the minimum or it wasn't, so the original element wasn't either the minimum or the maximum at some point. So we only want to remove from the left and from the right in the sorted array. So we can just do it in a straightforward manner. So we can sort the array, and since we have at most 3 moves, there are really only 4 options of what we can do. Because we can remove 3 elements from the left, 2 from the left, 1 from the right, 1 from the left, 2 from the right, 0 from the left, and 3 from the right. So we can just check which of those gives us the best result and return that result at the end. And this would work even if the number of moves was greater than that. So essentially we have to imagine that we remove those elements, and then from both sides we look at the first remaining element, get the difference between the greatest and the smallest, and that is the final answer. And it's also important here to note that we're sorting, so we use n log n time. However, it would also be possible to do a partial sort or a partition, because really we're only interested in the 4 smallest values and the 4 largest values. It's not that important, but partitioning can be done in linear time, so without this logarithmic factor. There are functions, for instance, in NumPy you have a function of partition, so you have NumPy partition. You also can implement your own, for instance, quick select to partition, or just the basic quicksort method of partitioning elements. And it's also possible to perform linear time partitioning by using a heap, because if we're here interested only in 3 elements, then of course we can create a heap in linear time, and then we only look at the constant number of elements. So it's just linear plus logarithm, but not linear times logarithm. But it's not really important. Here we can use sorting, it's simpler, and if we really wanted some more performance, then in that case we can think about partial sort.